Hello, my name's Mark Jones and I work for a company called Artificial Solutions based in Newbury. And we produce software which allows human beings to interact with computers in a very human-like way. And this process is called natural language processing. And we deliver millions of conversations each week using either web virtual assistants, mobile virtual assistants, even through to interacting with social media channels such as Twitter and Facebook. And as I said, we deliver millions of conversations each week, and we do that on very standard pieces of hardware and standard software. Now, even though we talk about these very large scales, I thought it would be quite interesting to see how far our software can go down and run on small pieces of hardware. So what I thought I'd do is I'd try to run our engine on something like a Raspberry Pi. Now what I've got here is a Model B Raspberry Pi. This is the 0.5 gigabyte version, revision 2. These are built in the UK. I think they're built at a Sony plant in Wales. And this is running Debian Wheezy, which is a pretty standard distribution of Linux for the machine. And on it I've got Tomcat. I'm running OpenJDK 6. And that's all we need to run our interaction engine. I've also developed a piece of software that listens to Twitter streams for particular tweets, and I'm going to use our interaction engine to understand what people are saying and even auto respond to them. Okay, so I'm going to do all this on a very standard Raspberry Pi revision 2. So let's take a look. Okay, so what you should see on the desktop here, I've opened 3 LX terminals up on the Raspberry Pi desktop. Over here I'm just displaying the version of Java. It's actually JDK, the OpenJDK 7.6. I said previously. I'm running top here to show you all the processes that are running when the application is running, and over here I've got the command line ready to run. So this is just running a Java file which will listen to the stream, and it will send incoming tweets directly to our knowledge base. Now our knowledge base consists of around 2,500 language objects and around 20 FAQs, which allow people to ask questions in various different ways, and I'll show that as we send tweets from a couple of devices inside into Twitter. So what I'm going to do here, I'm going to run the app, and that's just sitting there now waiting, listening to the stream. So what I've got, I'll just bring over to the camera. I've got a Nexus 7 here running Twitter. Now it's going to go to a special account called Mark_Artisol, and you can see here I'm saying, is it okay to take a laptop on board? So this is an FAQ for a fictional airline. Now on the iPhone I'm also posting from a different account here, and you can see here I'm saying, may I bring a laptop in the plane? Okay, a slightly different way of asking the same kind of question. So I'm going to tweet those now to the account, and they should be picked up, and you should see it on this window here. You'll also see a slight peak in performance, on the slight peak in usage of memory over here and CPU. So I'm just going to put the iPhone through, and you can see there's going to be a response down. If I just post that through on the Nexus 4, you can see there we've read it in and we're responding to that as well. Okay, so let's have a look at what's actually done in the background. So our natural language processing has actually seen that tweet, and as you can see, it's responded to that. And in fact, it's sent back 2 tweets because it's slightly more than 140 characters, and that's come from our natural language processing engine in real time. Now on the iPhone, it's done the same thing. Of course, it's responded in the same manner, but what it's done, it's understood that as being the same question. So our natural language processing engine has understood that and responded in the same way to the device. And that was all done in real time from the Raspberry Pi, listening to a real-time stream, and I haven't tuned anything here at all. This is a completely standard Tomcat installation, completely standard OpenJDK. There are some specific JVMs, I believe, for Raspberry Pi. So as you can see, we've got a natural language processing engine running, as well as an application that listens to streams and responds to them in real time. Okay, thanks.